of chapter 12 of physics. So this chapter belongs to the 10th class. So here we study the magnetic effect of a electric current. So first of all, we study about the some electric effect of a current like heating effect and other effect which are left in previous slide. In previous slide, we read about heating effect. Heating effect of a electric current, and we already explained when we pass electric current into a wire, then wire produce heat. So this wire produce heat due to the collision of a electrons. So like this is a conductor, and this consists many electrons. So when we apply voltage here, what happens? These electrons are accelerated toward the positive end. During the motion of electrons, these are collide and produce heat. So what is here? Collision of electrons produce heating effect. So what are the important applications of a heating effect? So applications of a heating effect like we use in electric iron, or electric rod. So electric rod used for the heating of a water, and electric iron used for the iron the clothes. And second, what is used in a electric bulb? And also used in what is fuse wire. So these are the some important application of a heating effect. So this already what these are used for the heating effect. They contain a what is alloy. When we apply voltage, then what happens? They produce heat, and these heat utilized in the heating of the water. And second, what is electric bulb? So electric bulb also contain materials like tungsten. So what is the role of tungsten material here? So when we apply voltage, then temperature of the tungsten material increase and they radiate energy. When increase the voltage, temperature of filament increase. Filament increase, like this is an electric bulb, and they contain a tungsten filament. So what happens when we apply voltage here? So they radiate light energy in different directions. So these are the important applications of a heating effect, and most important another what is fuse wire. So what is the role of a fuse wire? Fuse wire is used in domestic circuit. So domestic home circuit, And what is the main function? Avoid the heavy current. So basically fuse wire contain a alloy or a copper electric wire like this. So this is a fuse. They contain a wire of a copper or maybe other material which have low melting point. What is low melting point? So what happen by selecting low melting point? What happens when heavy current come? Then these wire break and circuit is broken, and over circuit like refrigerator, TV and other instrument are protected from the heavy current. So here what happened? We connected here number of electrical circuit. Like here we connect here electric bulb. Here this is TV and other instruments. So when heavy current come, these circuits broke. So by simply breaking the wire, we protect our electrical instrument by the heavy current. So these are the advantage or applications of the heating effect, and there are some disadvantage of a heating effect. And what are the disadvantage of a heating effect? For example, when we pass electric current, then most of the electric current are radiate in the form of energy. So for example, when we give 100% from the powerhouse, so what happens? 40% energy of the electric current consumed in the form of a heat. So there are nearby 30 or 40% loss of the electric current due to the heating effect. And second, so what is here first? So first, loss of electric current in the form of energy by heating. And second, what happens when heavy current flow? Heavy current flow, what happen? Then circuit or wires are short circuit. So due to the short circuit, many times wire catch fire and all things are damaged. So these are the main disadvantage of a heating effect. So these are the topic which are left in the previous slide. So next we read what is magnetic effect of a electric current. So this application also important. So what are the magnetic effect of electric current? When we pass electric current into a wire, what happens? These produce magnetic field. For example, we take a circuit. So when we close the switch, what happens? Electric current flow into the circuit, and here what is the direction of electric current? Electric current flow from positive to negative direction. So what happened here? Magnetic field produced. So first of all, this phenomena was discovered by the Oersted. So this is the scientist name. Oersted first of all find this effect. So also sometimes this is also known as the Oersted experiment. So how they discover? They discover accidentally. First of all, when he passed electric current, what happened? We kept here a needle. So we place here a magnetic needle. For example, this is magnetic needle. So when we close the switch, electric current flow into the wire. So what happened? This magnetic needle shift in a particular direction. For example, here direction of a electric current, what is? Clockwise. What is? Clockwise. So what happened? This magnetic needle deflect toward the east pole. For example, this is east and this is west and this is north and this is south. So there are 4 directions. So this magnetic needle shift toward the east pole and this deflection like this. And second, if we change the direction of a electric current, for example, how to change the direction of electric current? So here what happened? Change the polarity of the battery. So this becomes what is negative and this becomes positive. So what happened? Direction of a electric current change. So what is direction of a current? This. So this is what is anti-clockwise. Anti-clockwise. So anti-clockwise direction. So what happened? Direction of a current, what is? This. So if direction of a current change, then deflection also change. So here deflection this. So this pointer shift toward the west. So this show there is a field which apply force on the magnetic needle. So basically this magnetic needle made of a magnetic material. What is? Made of magnetic material. So here this experiment show whenever change in electric current in a wire, then magnetic field produced in a wire and which deflect the needle. So we can write this: when electric current is changed in wire, then magnetic field produced, and this magnetic field apply force on a needle. This magnetic field apply force on needle. So basically here what is force? So you already know. So force is a vector quantity and always measure pull and push effect. So this force apply on a needle and needle change the direction. So this phenomena discovered by the Oersted. So this is discovered by the Oersted and this is known as the Oersted experiment. So here question arise, on what factor magnetic field of a wire depends. So So first factor, on which factor magnetic field depends? So first, what is depend upon the amount of current. Amount of current flowing into the wire. Second, direction of the electric current. Direction of electric current. So if we increase the voltage here, like this is 100 volt, and we increase this is 200 volt. So at 200 volt, what is amount of electric current increase? If amount of electric current increase, value of a magnetic field around the wire increase. Second, if we change the polarity, this is the polarity of a battery. If we change this by negative and positive, for example, this makes negative and this makes positive, then magnetic field also change. Direction of a magnetic field also change. So these are the basics of the magnetic field produced by the wire. Second, how to find out the direction of a magnetic field? So we can use how to find out direction of magnetic field? So direction of a magnetic field can be find out using right hand thumb rule. So using right hand thumb rule. So what is right hand thumb rule? For right hand thumb rule, we take the thumb that show the direction of a electric current and finger gives the direction of a magnetic field. So we can make a diagram of it at. So for example, so this is right hand thumb rule. So for example, we take a wire. So this is a wire. For example, name of a wire, this is what is XY. So here electric current flow in the upward direction. So what is the direction of current here from Y to X? Direction of current Y to X. So here align your thumb in the direction of a conductor in which electric current flow and close your finger. Then these fingers give the direction of a magnetic field. So like this is a thumb. So what is the direction of electric current? This is the direction of a current. And this is the direction of a magnetic field. So for example, this is right hand thumb rule. So this is right hand thumb rule. So this is thumb. So which represent the electric current and electric current flow in the upward direction. So this is a conductor or a wire. So current flowing from downward to onward. So close your thumb, close your hand, and this show the direction of a electric current. So here thumb, wrap your finger. So here magnetic field form in the form of a circle. What is? So here. What is this is the direction of a magnetic field. So this is the direction of a magnetic field. So close your finger. So this finger gives this gives the direction of a magnetic field. So we can find out, for example, like this, or there are four types of conductor, Y, X, and same material. So this like this, and another this, A, B, C, D, and E, F. So for example, here direction of electric current this, here direction of electric current from A to B, and here direction of electric from Y to X. And here what is E to F. And here direction current from D to C. So how here magnetic field find? So this is your right hand rule. So place your thumb in the direction of a conductor and close your finger. So here direction of a magnetic field this. So this is what is anti-clockwise. Anti-clockwise. Here direction of a electric current from E to F. So place your thumbs in direction of electric current and wrap your finger. So this finger moving in downward direction. So what is the direction of a here magnetic field like this? So here like this. So they are moving like this. And again here. So here direction of electric current from A to B. So place your right hand in direction of A to B. So what happened? Close your finger. So here what is direction of current this, and like also here. So this here this. So these are the different direction of the magnetic field due to the different direction of a electric current. So next, so on the basis of the this explanation, we can define definition of a magnetic field. So what is the definition of a magnetic field? So magnetic field is defined as the space around the conductor in which its effect can be felt. So basically this wire and there is a magnetic field. So here we observe force of attraction or force of repulsion. What is effect means? Force of attraction and force of repulsion. So this is basically what is space around a conductor or a space around a magnet in which force of attraction or a force of repulsion we can experience. So next, what is magnet? So magnet also a materials which produce force of attraction toward a different metals like iron. So produce force of attraction toward some metal. What is some metal? So these metals may be like iron, nickel, cobalt, and chromium. So these are known as the magnetic metals. So what happens when we use some particles of this metal nearby this magnet? So what happens? These are attracted by the piece of a magnet. So there are some type of a magnet like natural magnet and artificial magnet. So artificial magnet may be bar type. So that is a rectangular shape. So they consist what is north pole and south pole. And other magnetic material like these are known as the natural magnet. So this is what is artificial, and second what is natural magnet. So natural magnet may be like Fe2O3 and Fe3O4. So these are found in the earth crust. So these are found in the earth crust. So these are known as the natural magnet. Second is what is artificial. So they are made by the man. And what they consist two pole. Two poles. These poles are known as north and south. So north and south. So they consist magnetic field, and these magnetic field show by the imaginary lines of the field. So this is what is north pole and this is what is south pole. So here important what is, when you take two magnet and bring close to each other, what happen? They are attract or either repel. So like these are two magnets, north and south. And second, this is north and south. This is also south and north. So what happen when two magnets bring each other? So we bring each other. So what happen? These are opposite pole. So opposite poles always attract each other. What is? Attract each other, while these are same pole. So these are same poles. So same poles are repel each other. What is? Repel each other. So here we conclude that like pole repel each other and unlike poles are attract each other. So these consist. So here what is? Here a field. What is? Here around the magnet field is present, which are invisible, but they are shown by the imaginary lines. So how they shown are in imaginary lines, like, so this is magnet and this like a conductor and this is a magnet. So like this wire may be contain many circular loop. So they contain many circular loop. So here this is what is north pole and this is south pole. So here we already tell, here contain a invisible field. So these fields are shown by the imaginary lines. So these imaginary lines are like this. So these lines are known as magnetic field. What is? Magnetic field. And what is the direction of a magnetic field from north to south? So there are many lines. So also these wires also contain magnetic lines similar to the magnet and known as the magnetic field. So for example, this act as a north and this act as a south. So direction of a magnetic lines of from north to south. So this is an invisible field which are shown by the imaginary line. So this is an imaginary concept. So next we study about the force applied by the magnetic field on the conductor. If you have any query, then please comment on the boxes. And in next slide we study about the applications of the magnetic field and other phenomena. Thank you very much.